Hello, and welcome to my lightning talk about how to turn computer programs into physical objects. Is it working? Okay. Oh, it's working. It's just delayed. So, it's a lightning talk. Let's do this quickly. So, okay, why do you want to turn programs into physical objects? So, this might be a clue for the future. So, I got a GPU. I got this weird GPU. It's a GPU that, yeah, if you were NVIDIA, you wouldn't like this to exist because it's a consumer GPU in the blower factor. This means it's a single slot GPU that is very, very loud, but you can put a lot of them into a machine, and that's something that NVIDIA would like to have like in data center GPUs, not in consumer ones. But lead tech doesn't care. They produce these these GPUs. They will end up in industrial computers. The industrial computers break. They sell them to 4 parts because they can't RMA them in some cases, and that's how I got mine. So I got a nice GPU. The GPU was super noisy. So what I'm going to do about it? So I can handle it by software. At least it looked like that initially. This is original email from lead tech engineers. Apparently, like, you can really email them and they will tell you, yeah, sorry, this is industrial hardware. We don't care about noise. We just want it not to melt. So yeah, software solution was not apparent. So I have this stuff and I want to have hearing after using it for a couple months. So what to do about it? So there is a very, very noisy turbine fan. You can see it to the right. And there is a huge vapor chamber cooler. So ideally, you want to replace the fan by something that is spinning at slower RPM, so you don't get diffness from it. And ideally, you would also increase the fin area. Problem is not really a space in my case. I'm not cramming more of these into a machine like they did in that industrial computer that failed somewhere. Ideally, you want to have bigger fans to a degree, but that's for another talk. And you want to ideally have a bigger cooling area. So like, how do you do that with something that was not really built for it? In any case, yeah, this is a problem. It can be solved by 3D printing like any problem. But ideally, you need to be able to work with Blender, with with some CAD software like proprietary or open source. Like, the problem is I can do that. I can do some 2D drawing at most. But I'm a programmer, so let's do this. Let's program the 3D models. Let's write a program that outputs a 3D model. So this is an example picture from the OpenSCAD website, and this is their logo. And the logo is a 3D object. The 3D object is generated by this code. And so OpenSCAD, it's a special type of CAD software, computer-aided design, where you program 3D models. You write a program. It's not really a configuration file. It's not really a program. It's both. You mesh together basic 3D objects, and you get anything, basically, as long as you mesh enough of them together and not get insane doing that. It has what you would expect from a programming language. And you can have variables. You can do mathematics on them. You can put comments inside, so it's still readable. You can have functions and create parts of the object. And you can also include stuff from other files. You can do much more. Again, we don't have time for that. There is an example of plain OpenSCAD format. That's the stuff on the right is some sort of wheel with holes in it. This is how the program looks like. It demonstrates all the things. So you have some mathematics there. You have comments. And the output is the stuff on the right. So the OpenSCAD is the programming language, let's say. It's also the tool. So you write the code in the tool can render you a preview of the object. Then you export it into STL or something else, and you 3D print it. So the thing is, it's really, really basic. Like, you really are meshing together spheres and cubes, and it will work. Like, you can do anything in C or assembler or machine language, but it's not nice. So you will start writing your own libraries so you don't get insane. But maybe someone did that already for you. So like, it's this. It's a library for OpenSCAD. It can do anything, as far as I can tell. Anything easier than OpenSCAD can do anything. We can build you screws, you can do meshes, funnels, everything in a very nice way. So, for example, this might look weird, but if you did some 3D printing for multiple parts, this is the basic thing you can do to put stuff together with bolts. You will just tell it like which bolt you want. You don't need to like measure every bolt you might want to use. It will output something like this. The code, again, on the right is the same as the 3D object on the left. So, okay, I had this GPU. Let's get it cooled. This is an example from me building this 3D cooling solution. This is just part of the program, but this is the function that creates the funnel for the fans. Another function that actually makes it hollow, otherwise it would be full. So somewhere else there is some diff between the one and the second one. And there is a whole bunch of variables that you can use to tune how the angle of the fan, the size of the funnel, the position from the GPU. The GPU is on top. This is the original hole for the turbine fan. And this is how it's being printed. Again, see, nice 3 supports, not the topic for this talk, not enough time. And this is the secondary block. So like, this is the thing fixing the fan by putting on a bigger fan that is spinning more slowly. And this is fixing the fin area. So basically, I got 4 NVMe heat pipe coolers, and I just like press them from the bottom to the GPU on the side where there is like this thick but very small cooling stack. This is already being installed in a computer. It's basically using all the space under the GPU. And like there is nothing I need to put there, so that's not a problem. On the left, that's the funnel. On the right, that's the cooling stack from behind. And there is a 80 millimeter fan in front of it, so there is 2 fans. This is the complete solution in a normal ATX case. Yeah, for scale maybe. All the yellow parts are 3D printed and OpenSCAD Bostel 2 designed. Some conclusions. You can control the fan separately. The header on the GPU is not used. There is software running on the computer based on the GPU temperature, which it can read. It will run the fans with some reasonable fan curve. It's totally usable finally. In idle, it's almost unaudible. Yeah, 3D printing solves all problems. But most importantly, it was a very, very nice learning experience for me. And yeah, it can be also for you, especially if you really are into programming. You haven't touched some CAD software or 3D modeling. This could be a way for you to start building 3D models. Also, from the presentation so far, it kind of looks like, so you learn something, you program one 3D model, you print it, and you are done. So in practice, it's not really like that. It's like kilograms of filament and incremental modeling. But this is also how you learn to program. Like, not the first program you will write will not be perfect, but over time you can get it to be perfect. And yeah, that's it basically. If you have any questions, or if you want some of the prototypes, like you can take them as a keepsake, that's not a problem. That's a use for them. And yeah, that's it. Any questions? Yeah, please go ahead. It's all PLA. So, okay, the question is what material has been used. I've used PLA because from my experience, it's easiest to work with. I was a bit afraid about temperatures, but like with all the air going through, yeah, it's not melting so far. Any other questions? Mm-hmm. So basically, M2 NVMe devices can get quite hot, so they are making heat pipe-based coolers for them. So what I did, I basically designed a throat that is pressing these against the GPU, and it's also doubling as a GPU support because today's GPUs are massively heavy and can possibly break the slots on the motherboard. So this is doubling as both the additional cooling stack that hopefully reduces the temperature by a couple degrees by pressing those coolers from the bottom and providing a space for a fan that like injects air through them and out of the case. And it's also supporting the GPU so it doesn't break the motherboard. Okay, I think that's it for the questions. So thanks for attending the talk. And yeah, we can switch to another speaker. Thanks.